And then protractor. So you have 4 centimeters. And then you need 45-degree angles. So then you take your protractor. There's a dot over here. Okay, Edwin, do you need something? Yes. Yeah, come on up. 45 is between 40 and 50. I'm going to mark it on the top where the little longer line is. Thanks. And then I'm going to connect like so. That's 45 degrees, so let's do another 45 degrees on the other side. And then 45 degrees on this side. So this is 45, this is 45. So what would be the measurement of this top angle and why? And why? Yeah, so you have 45 and 45, right? And then this one's like unknown. So 45 plus an x is equal to 180, right? So you know 45 plus 45 is 90, plus x is 180, and then you go, huh, what plus 90 is 180? 90. And of course, a lot of us can do this in our head, but I wrote it down for everybody to see, like, oh, I see what they're doing. I see how they got to 90. So this would be 90. So what symbol can I put in there instead of writing a number? Little right angle box, right? Do I need to take away the... If I take them away, I still expect you to do it correctly without the tools. So don't play with it. So this is 90. So what do we call this right triangle? Go. Oh.
You said it.
I only gave you one name though. Ha. Shame on you. Yes. Why is it isosceles? So here's the relationship. If there are 2 angles that are equal, then that means that 2 sides are going to be equal. This side and this side are equal to each other. So if 2 angles are equal, then the 2 sides are equal. So then we call it an isosceles triangle. So isosceles right triangle. We're okay? All right, let's do number 5. Number 5. A triangle with a base of 4 centimeter base angles of 60 degrees. Don't play. Don't play. Eddie. Okay, so we're going to measure out 4 centimeters. Just like before. And then 60 degrees. The number one way you can mess this up is using the wrong angles, like you're not using the inside numbers or the outside numbers appropriately. You should be getting acute angles. So if you end up with an obtuse angle, you know you did something wrong. So this is 60 degrees. This is 60 degrees. What? Okay, so if this is 60 and this is 60, what is this one?
60.
60.
60 equal to 180.
Mm-hmm. 60, 60, 60, right? I mean, if you need to go into the math, it's basically 60 plus 60 plus x equals 180, and that's how we came up with 60, right? Yes.
Since the base is 4 centimeters and all the angles are the same, are all the sides the same?
Yep. There is a connection between angles and sides. So all these angles are equal to each other, right? So if all the angles are equal to each other, then all the sides. Now, if you measure it, you really, you see that it's, I mean, if you're awesome, like me, you'll get 4 centimeters. And then over here, you'll get 4 centimeters, right, Jose? But my last period, when I did this one yesterday with my second period, I didn't get 4 centimeters. I got like 4 point something, which means that my angles were a little bit off. Eeks, my bad. But we're going to count that because we know it's 60, 60, 60, 60, 60, 60. We know this side and this side are equal and this side is equal. So we're going to do like the little hash marks. So what do we name a triangle that has all equal sides? Equilateral?
Acute equilateral.
Equilateral, acute. All the angles are equal, so all the sides are equal. Can you have an equilateral obtuse?
No.
Can you have an equilateral obtuse triangle?
No.
Why not? So, an equilateral, let's just focus on equilateral, means all sides are equal, so therefore all angles are equal, right?
Yes.
So if an obtuse, that means they all have to be obtuse, right? All the angles have to be obtuse to be equilateral. So let's make it 100 degrees. Can I have a triangle that's 100, 100, and 100? No. Okay, so can I have an equilateral, right triangle?
No. Yes. No.
So if it's equilateral, that means all the angles are equal, right? If it's right, that means there's a right angle. So can I have a right, and a right? No. Mathematically, it doesn't work out. And
Unless it's a pentagon.
well, we're talking about triangles. So there is only one choice for equilateral. So if you have an equilateral triangle, no matter the size, it will always be acute. And the angles will always be 60. There's no other choice. So an equilateral triangle will always have 60-degree angles because that's the only combo that works. Now, it could be like 10 centimeters, 10 centimeters, 10 centimeters, but the angles will always be 60. Jose, enough with the iPad. All right, moving on. Now, you know how I always tell you to start with the longest side?
Yeah.
Okay, for this example, we're not. We're going to start with AB. We're going to go in order. Maybe, if I remember. Or is it this one that has to go in order? Can't remember which one, 7 or 8, has to go in the order that they give us. It's fine. We'll start. AB is 5 centimeters. So we'll start with 5 centimeters. All right, Jesus, iPad. No reason to be on your iPad. AB is 5. Let's do it. Okay, so I'm going to label this A, B. So this is A, this is B. Could I done BA? Yeah, doesn't really matter. It matters from here on out. How we start it, it really doesn't matter. So I did AB. Now it says BC is 7 centimeters, right? So I'm going to set it to 7. I know how to do that. Okay. So it's 7 because BC is 7. Okay. So where am I going to put the bump? On the A or the B? The B. Because it's BC.
Has no A in
It has no A. So put the bump on the B. And I don't know where I need it, so I'm going to draw a pretty big arc because I don't know if it's over here over here, over here. I don't know where my third dot's going to go, so I'm going to draw a pretty big arc. All right. Angle BAC is 90 degrees. BAC. This arc represents what letter? C. So this is C. Now it could be C over here, 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 here. Somewhere on this arc, it's C, right? You guys understand that? I just don't know where it's at, but it's somewhere on here. Okay. Angle BAC. Now when we did angles, do you remember when we named them? It used to be in that order. So this angle BAC is BAC. So you trace it in the order that they tell you. BAC. BAC somewhere up here, right? So this angle that I'm tracing has to measure what? 90. So where does the 90 degrees go off from? This A, right? Because it's BAC. So BAC. Oh, that means right here has to go my 90 degrees. So somewhere over here has to go 90 degrees. Why? Because it's angle BAC. Here's BAC. BAC. Okay, so go ahead and do a 90-degree angle in there. When they name angles, the middle letter is your vertex. The middle letter is your vertex. And some of you got that on the map test. In this period or my other period, they had to like label the parts of an angle. A ray, a vertex. If you didn't get it, that's fine. It's a 7th grade question. You might have gone higher questions or lower questions. But that's, guess what happened? You know why I got a headache?
Why? No donut.
No, I had a donut. And coffee. And juice. No. I looked at the map scores, the red, green, yellow squares last night. That's where my headache started. Now it makes sense. Maybe in 10 minutes.
I went up. I was surprised. I know, me too.
Did you try this time more than last time?
Yes,
It's all about.
I went up at 18.
It's all
I
about.
went up at 13.
I went up really high.
Oh my word. You went like 100.
I got like 100
Carly, he got like 100. Wait, did you get 185?
I think so. Or 185
You say it
or
so
190 or 190 something.
I got like 248 in terms of math.
For Spanish?
So right here, kids, let's stop making my headache worse. So I made a 90-degree angle here, and I went all the way up to where the arc is, Eddie. So draw your 90-degree all the way to your arc. That's your third point. And this would be C. So, and you can go back. BAC. Is BAC 90 degrees? Yes, BAC 90 degrees. And when I connect B and C, when I go back and measure it, it should measure exactly 7 centimeters. And it does. 7 centimeters. And this measures 5 centimeters? That's what I got. Did you guys get 5? Yeah, 5. So what do we call this triangle? It's 90 degrees, so you know it's a right? That's an obvious. And then how many sides are equal? 2. This and this side are equal, so it's called isosceles. Did any of you see these vocabulary words on the map? Okay. All right. Try starting number 8. You're going to be doing this similar to this one. Very similar to this one. Yeah, start in order. Just because you're a little different. So start with AB. AB is 5 centimeters. AC is 3 centimeters. So there's A. So I'm going to do 3 centimeters on my compass. Put my bump on the A or the B. on the A. Don't know where it's going to go, so I'm just going to go somewhere. All right, now, this is pretty easy, right? Now, the next part's kind of tricky. It says the measure of angle BAC is 120. Where is BAC? BAC. Oh, so it's still on this side. It's not like this one where we worked on B or on the other side. We're working on this side too. So BAC. So in here, even though we already used the dot, you know how like don't reuse the dot? I gotta reuse the dot. I need 120 degrees on this side. On the side you already used, which Jesus is really weird because we usually don't use the same side twice. It's weird. Weird. So draw me 120 degrees here. What are you gonna name it? Even before you make it a triangle, what are you gonna name it? You already know it's obtuse, right? Why? Because you're drawing a 120 degree angle. Use the inside numbers. So I'm going to make this 120 degree and I'm going to stop where the arc is. Miss O'Malley, my arc doesn't connect. We'll make your arc bigger. So this one, you got to stop where your arc is. But Miss O'Malley, my arc stops over here. Cool. Go back, make your arc. Look, I barely made it. I would have had to gone back and had to draw a bigger arc. So this is the top. This is letter C. So this one's a little tricky because you're using the same dot twice, which is not what we're used to. Close it up. This one, like we said, is obtuse. Let's see. This is 5. This measures about 3. And this one obviously is going to measure a lot more. It looks like it's 7.
So, obtuse statement.
Mm-hmm. Now, I want you to understand, these are the 2 hardest ones to draw of the whole packet. If you were able to do number 4 and 5 today and feel okay about 4 and 5, then you're okay. It's fine. These were like next level, super hard, but super awesome to do. So don't stress out if you're like, what just happened? How did she? It's fine. If you are able to do 4 and 5, you're in a great spot. Okay? Is there any more construction? Aw. Boo. I don't want to do this yet. Let's go. Let's do some drawings on the back. Can you? So you have the pink paper, right? Can we go to the? If you flip it over, it's a blank white paper. I did this on purpose. So go to the pink. Huh? Yeah. Yeah. Terrible. 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 Draw. Base is 5 centimeters with base angles of 50 degrees and 30 degrees? Let's see. I don't know. I'm making this up, so I don't even know if it's going to work. I mean, it's going to work. I don't know. So, can you draw? So, we're going to go back to, like, the simple ones, not super difficult. So, everyone should be able to do this. Draw a base of 5 centimeters with base angles of 50 and 30 degrees. So, this is, like, number 4 and 5. So, you can go back, look at 4 and 5. 5 centimeters. We're just practicing. Because this is, like, what's going to happen tomorrow. 5 centimeters, and then we're going to go to 50 degrees, which is there. And then 30 degrees, which is there. Did I do that right? Of course I did, Miss O'Malley. Have faith in yourself. Boom. So this is 50 degrees, this is 30 degrees, and this is x. Can you find the missing angle and then name it? So what's the missing angle? So the missing angle should be 100, right? Because what's 50 plus 30? 80. But I need to get to 180. I already have $80. How much more money do I need? $100. So that means my angle is 100. So what do we call this? The obtuse makes the whole thing obtuse. Right? Even though you have two acute angles, doesn't matter. If one of them is obtuse, the whole thing is called obtuse. How many sides are equal? None. I'd even measure it, but how do I know that no sides are equal? Because no angles are equal. So if no angles are equal, no sides are equal. So we call it a scalene. So this is called a scalene obtuse. Because I know it's 30 and 50, right? So I know that in a triangle, if I add my two angles plus my unknown angle, I get 180. And if I add these two, I get 80 plus what number is equal to 180. So in math, that's what we like to do. We like to build upon your skills. Like, okay, you learned how to solve equations in November. We're using it now when we're doing geometry. And that's how it's going to be for the rest of your life. All right, let's go back to like the super easy ones. Can you draw me a triangle that is, draw a triangle that has the measurements 3 centimeters, 6 centimeters, and 7 centimeters?
Yeah, it's gonna work.
Yep. It's gonna be a funky triangle. What do you know? Before you draw it, what name can you give it just by not even drawing it? Scalene. Now the angles, you can't determine the angles until you draw it. Until you see it. You can't. Huh? It's going slowly away. But I did. I think I just need to drink more water. Boy. Because this is your test tomorrow. So are you okay? Can I give you like either a question like the first one or like this and you'll be okay? This one? So this is 7, 6, 3. We knew it was already a scalene, right? Now, is it acute, obtuse, or right? Yeah, this one's acute, right? Super easy to figure out. This one, acute barely. Now the top one's the one I'm kind of questioning. What is that? Yeah, that looks acute, right? This one right here. The one you drew, acute? Yeah, so they're all acute. Could you have determined that by just looking at the numbers? No. You have to draw it. Acute. Are we okay? We're good? On the S-back, they could... Obviously, on the S-back, you're not drawing them. They're already drawn for you. You just have to be able to recognize if it's scalene, isosceles, equilateral, and then if it's acute, obtuse, or right. Any questions? You okay? All right. So you guys want to look?